I'd like to talk about another type of boundary, and this is called a divergent plate boundary. Divergent means that it's going to be moving away from each other. So these geological plates, these tectonic plates, are moving away from each other. Where that's most apparent is in the mid-oceanic ridge. It's just the only reason it's not apparent is because it's way down underwater. However, if we can look at it a little bit more closely, we'd see. Let me just draw the context here. We've got a oceanic crust, and there's this area right down the center there, and close to the midway point, where there's a section of it that sort of is risen up a little bit. Now, to give you an idea of scale, from say here to here can be any distance from 1,000 to 4,000 kilometers, to give you a little idea of scale there. Now, what I've drawn here is the oceanic crust. Okay, now underneath that, let's just change the color here. We've got the Oceanic Lithosphere. Okay, and that would also rise up in the center here to provide like a pathway for extremely heated rock. So this is going to be the Oceanic Lithosphere. Okay, and then down below, underneath that, is the Asthenosphere. Okay, so in this Asthenosphere, we've got a circulation of heat, a churning of all this material, and you can imagine it. Anything that's been heated is going to want to rise, and then cools, and then it just continues to churn and churn. But in some areas, there'll be a possibility for it to escape and rise up to the surface of the ocean floor. So let's just give some a little more perspective here. Maybe this is in very deep ocean, so there would be your water surface. Not quite to scale, but you get the idea. Okay, so then if we could also put this into a three-dimensional block. Okay, so the ridge would be somewhere along here, and it would look something like this. Okay, and with new material, as a result of an upwelling of this hot molten rock, we've got along the mid-oceanic ridge, it's called, we have this rift valley, and it is the location where all this new material is coming up to the surface. And this is basically creating brand new oceanic floor. Okay, so then it comes up and of course cools here, and then more will come up and take its place and basically push this material out to the side. Okay, and this these plates get pushed and pushed away from each other because new material is coming up from the bottom. All right, so and this movement can be anywhere in the order of let's say 5 centimeters to anywhere to 15 centimeters per year. Now, that may not seem like very much. If you only traveled 5 centimeters in a year, you wouldn't think you were going very fast. But geologically speaking, that is tremendously fast. Okay, so fast that there's no oceanic floor that has been age dated to be above 180 million years. So basically in the last 200 million years, we've got our current oceanic floors and basins having been created. Okay, so now the reason why we have this ridge is simply because there's an upwelling of hot material. So this heated material is going to be lighter and is going to want to come to surface, and it lifts up on its way a little bit and creates this sort of ridge that happens along here, and then we have this new spreading center, it's called. Okay, and that's basically the idea of a divergent plate boundary, and this occurs in the mid-Atlantic Ocean, and basically describes how new ocean floor is created.